this one is currying 2. Currying is something we've seen before. We had a challenge with Anthony Fu, the creator of the TypeScript challenges and overall TypeScript superstar. And we did some preliminary discussion, but a lot of you in the comments on that video said you want more. So this is more, currying 2. So currying is named after this guy. His name was Haskell Curry. And you may know his first name was also the name of a programming language. And so basically what it is we're going to take, it has a bunch of stuff here. I'm a very test-oriented individual, so I want to just look at the test. So let's look. We create this function called dynamic params currying, and then we get something out. We get curried 1 out. Curried 1, look at all the different ways that you can call curried 1. You can call it with each individual parameter as different function calls. You can call it with the first 2 and then pass it the last. You can call it with all 3. Whatever combination you want. You could also do 1 and then the last 2, any combination. And see, that's what we see here. So there's we have one with, I don't know how many there are here. 1, 2, 3, 4, 5, 6, 7. Okay. But you can pass all of these things in, and the idea is that it's all type checked. And you can do this kind of infinitely. What do you think?
Yeah. I love currying because I'm kind of a functional programming languages nerd, so
I knew you would say that. Busted.
So I definitely see the utility in this, which might not be obvious if you look at this in the abstract. But actually, it's pretty nice because we often have to kind of partially apply functions in order to pass functions to other functions. For instance, if you're mapping on a list of numbers and you want to add 1 to all of those numbers, well, you could create your own lambda function that does that, or you can write add function that you already have inside like a lambda only used once, and you pass that to your array.map. Thanks for illustrating what I'm talking about. But if you have a curried function, it's much nicer because you can partially apply your function and pass the returned function to map. So the code looks nicer, in my opinion.
I'll show, it's so easy to show this that I can't help but 1, 2, 3, 4, 5, whatever. So this is exactly what you said, that you can just pass in add 1 here.
That's right.
So to people watching, if you haven't seen something like this before, hopefully it is very mind-blowing and opens your eyes. But this is really neat because otherwise what you would have to do is you would have to say value, you would have to say add 1 value.
Yeah.
Right. So those are.
Yeah, sorry. For an example as simple as add, obviously it seems a little bit overkill. But when you have functions Lodash functions that do a lot of smart things, and you no longer need to try to bundle them, to call them within a lambda function. The code just is just smaller. So it's
there's a really important fact about how all of this works too, which is that if you could set this up so that there's actually we could make this be a function that returns a number, right? So if we do that, let me just demonstrate number. Oh, we'll have to just call it. So if we do that, it's going on to the next line. Let me see. What Gabriel's talking about is really important if you have a database and you're calling the database. So let's say we do inside here, we do some database call, right? Or we do some work. Now it's just returning a constant, but we could say fetch, something like that, whatever. If we're doing some work inside here, if we do it this way with currying, it will make the fetch call once, grab the value, and it's kind of cached there, and it will use that value every single time from that point forward just once, right? We've already grabbed the value by nature of the fact that, this isn't complete because we have to resolve the promise and whatever, but we will have already grabbed the value, so we can use it just once. So it's kind of like declaring a variable outside of a for loop that has extra computation involved, so you don't have to call it within the for loop every single time you need to iterate. Okay. We're both nerds for this stuff, so we could probably talk longer. But I mean, broadly speaking, I have a bunch of solutions to show you. So I'd rather like show you them and we can talk through them. But like, what would be your thought process for breaking down this problem?
Well, actually, I'm not sure because I've never solved that one. So first, the first thing that we need to do is to extract the list of parameters from the function that you give to dynamic param currying. And then you need to, I think you will need to return something that's like an overload of several possible cases, maybe. So I know that you can compute overload with by intersecting several functions together. So that's kind of a trick to generate overloads dynamically. So I was thinking maybe we could generate an overload for all partial applications and return the intersection of those functions. So I think that would work. It might not be the best way to do that. Otherwise, what you can do, well, actually there is another idea. It's to return a function that takes like a variable number of arguments, and you just need to start with the list of arguments that you extracted from your function, and you make this list of arguments a type parameter, and so you use the length of this type parameter in your return type to decide if you are returning a new function because the arguments are incomplete, or the output value. So I think that would work too. It may seem a little bit more efficient. Yeah.
Okay.
That's 2 ideas.
So what I think like the what you suggested is sort of close to what some of the solutions are. They're actually, these ones have fairly different solutions. I think different enough anyway. So what I'd like to do is kind of start walking through, instead of just pasting it, I'll sort of like maybe we can read it slowly as we go.
Yeah, that sounds good.
So okay, so all I did is I gave this function generics so that we can grab the value of t. Like you said, we need to extract a list of parameters. That's what both of these have in common. Other approach. Okay, so we have the list of parameters, and we also have now a return type as well. So now we need to actually implement it. So let's come here, t extends. So we have to handle the case where t is an empty array. If it is an empty array, then we don't need, there's no work to do. There's no params needed. So we can just, it's the same. And now it's like identity function because it's just something with one argument or 0 arguments. So, okay, that's easy enough. But then
have to return a function type initially, because like you are extracting the list of parameters and the return type from the function that you give to dynamic param currying, but this function returns a new function, right? So we would need to return a function anyway.
Well, we need a base case of recursion.
Yeah, but I think it's within the function type that we are going to return, right? Like, let me
Okay.
show you what I mean. So for instance, if you do dynamic param currying here, and you do that on ABC, I don't know, this returns string, but then you will have to call F2, right? Even if this is like, well, in your case, even if this function doesn't take any arguments, the return type of dynamic param currying is still a function, right?
That's true. So it would be a function returning R, you're saying?
Well, I think I would return a function anyway in the auto expression, like here, for instance. And this function, yeah, well, you could do that too. I think that works. That works as well. Yeah.
Okay. Yeah, maybe so. if no params. Okay, yeah, let's keep looking, and I think that might work. So we have to grab. We don't know. I think extends unknown array is here because we're going to grab the args again. So we have p. And then inside of what it returns, this is where the magic is going to happen. So we're going to say t extends p. Not page. Does that happen to you? It happens to me all the time.
Yeah,
So they called it K3. I don't know why. So this solution that I'm showing, by the way, is from this person. I thought it was the cleanest one. So, oh well. And then basically what they're saying here, let me copy the comment that they put in here. So they said, check does P and K3 extend T, basically checking if P is fully T, meaning like, are we done recursing? Have we hit the last element? If so, then they did a little trick. You see?
Yeah.
So I think
That's interesting.
I think that works. K3R. Let me just. Oh, okay. So maybe this is where this comes into play. Yes.
Yeah.
So because of this solution, I should have shown you the trick first, I suppose. But this is a bit of a hack because actually this is like a kind of recursion here. We have a function. We're calling the type of on the function. Yeah, what does happen there? Let's look.
Yeah. So the issue with this solution is that it's incorrect if your function doesn't have parameters, but you probably don't want to pass that to a currying function anyway in this case. But yeah.
I love that you found that. Okay, so let's keep your thing here, and let's keep looking at other solutions. So I'll show you another one, and maybe we'll see if other ones solve this. So that solution. Let's see. So this one is from KKAILL on GitHub. Let's see if this one solves that same problem. No, this one has the same issue. Okay, but let's look through it. So you take a look. Tell me what you think about this one.
Okay, so let me try to understand. So this is pretty much the same thing, except that we extract the argument and the return type from a generic function type. I think that's what I would have done too, naively. So args, and then you call currying, which is this generic. And yeah, so it's taking the arguments of another generic function that we create, and yeah, it's doing pretty much the same thing, right? It's inferring the tail, and if there is a tail, you return it. Well, you call currying back, which is going to return a new function with different arguments. So you return a function for those new arguments. Otherwise, you return never, which that's interesting. I don't know what happens exactly if never is written.
I think that never. I mean, what is the situation that never could be written?
Well, if you reach the end and you have no longer any arguments in the list, well, no, this would be an empty list, right?
Right. So I think that this is just, it could be like, I bet you we could put anything here and it would still pass. Yeah. So this case never is reached. Yeah. We're only doing it so that we can infer out the tail.
Okay, that's interesting. So it's that makes sense. Okay. Yeah. And if T is empty, we just return the results. That makes sense.
Yep, exactly. Because otherwise, there are no values. Some people, by the way, put like infer. They'll put some value here, and they don't know that like you don't have to actually put any values in there. I guess infer y array doesn't work. Yeah, because it's expecting some values, but that would be infer unknown array. But anyway, you can just put unknown here if you want to grab arbitrary values if you're just counting. All right, that's the second one. I have the last one here, and this is by our guy teamchong. Look at that. His works. I told you. I love that. So Gabriel and I just did a video for was it run length encoding, and basically it was exactly the same thing. I was telling him that this person's solutions are usually different than everyone else's, and it passes the edge
And
case.
that's funny because he is doing what I was suggesting. I think he's doing an intersection of different functions, and this creates an overload for all possible functions. I think no.
I was gonna say when you said that, I never looked at it that way about how the intersection works, but yeah, I guess that's what overloads are. Overloads are intersections of function declarations. Yeah, that makes sense. So that's how you declare.
Like
Oh.
if you create a type fn, which is two function types intersected. So you have a let's say string, and it returns string, and you have a function that does the same thing for numbers. So it's basically an identity function that accepts strings or number. Well, I'm going to do declare const fn instead so that we can call this. And yeah, if you do that, it's going to be exactly like an overloaded function. So if I pass a string.
Oh wow! It even shows as an overload.
Yeah, exactly. And
wow.
I don't know if that's an implementation detail that kind of leaks, or if if it was meant to be that way. But that's an interesting property of intersections of functions.
Wow. How did you know that? Where do you get this? Okay, so I learned it from you. Where did this person learn it? This is so amazing.
Well, I've been playing with unions and intersections of functions to try to kind of better understand how like assignability and type variance works, and that's how I found out about this.
Wow, I'm so impressed. I never would have thought that's because some things are like, I don't think there's a way to generate enums, for example. Please surprise me if I'm wrong, but there's not a way to in the type system like arbitrarily generate an enum, which makes sense because enums are like constant values. But I didn't know there was a way to generate overloads. This is groundbreaking. Okay.
Yeah, I'm not sure it's extremely useful in practice, but it's still nice to know.
I think it's useful for libraries that have. I think it's probably the more useful than some of the other skills we learn in these challenges doing stuff like this. But yeah, I think that's really amazing. Okay, so he's doing what you suggested. He's generating overloads with an intersection of functions, and that allows. So how does this case? Can we look through this case, just to do one for fun? So your edge case.
Yeah. So this one works because the edge case is also a function that returns R.
Yep.
Right? And this is basically creating a signature for every possible partial application by adding the head of the list to the list of arguments. So initially, it's going to be one element because args is empty, and then two, and then three, etc., etc. And we just intersect all the results together. And I think that's why this case works as expected.
Wow. Incredible. I'm so impressed. Okay. Well, I can't top that. That's the last solution that I had for this one. Any closing thoughts?
No, nothing clever.
Do you have would you use a function like this in any code bases of yours for like auto-currying?
Well, yeah, I think that does make a lot of sense. I think that's okay because like you could be a little bit worried about like type checking performance with that kind of types that can be pretty heavy to compute. But at the same time, functions don't usually have a ton of arguments, so it can be it will rarely cross 10 arguments, right? So I think that's totally fine. And well, the nice thing about this is that once it's written, like I would definitely comment this code a lot and try to give explanations on how it works and stuff. But yeah, once it's written, hopefully nobody really have to edit it. Well, you still have to look at the at the codified type error, but
Yeah.
it depends how like what errors look like with like if you are passing a wrong argument, for instance. I'm wondering how
What it would
like
do?
yeah.
Yeah. Let's pass a number here. It gives you an error. Oh wow, that's nice. It gives you an error at that position. It doesn't give you like a big error that you have to read through. That's
Yeah, so in
cool.
this case, it's definitely good. I think it's definitely usable in production.
Wow, that's actually really nice. Yeah, I guess that makes sense because the error is on the argument. Well,
Mhm.
super neat. And yeah, I think based on what you said to the about the number of arguments not usually being that large. Many years ago, I tried to port Ramda. You know Ramda,
Yeah.
the like functional Lodash. I tried to port it to Go because I was writing a lot of Go at the time for my job, doing Kubernetes. That's what that is back there. But I was writing a lot of Go, and I really wanted some of the functionality that Ramda has. And I found a problem, which is that Ramda looks like it auto-queries a lot of things, and it looks like it can do that infinitely or arbitrarily, but it actually can't. It does it up to 10 arguments, and after 10 arguments, it throws an error.
Mm.
And I used Ramda for many, many years on production in many things and the team using Ramda, and we never hit any problem like that. Nobody even knew. So it goes to your point that like it's usually like 10 is a pretty big number of arguments to pass in, especially variadic arguments. It's usually not going to happen that way. So, oh well. Cool.